The next topic we'll be talking about is absolute value. So let's go ahead and define that. So the absolute value of an integer is its distance from 0 on a number line. So one thing that's true about distances in general are they cannot be negative. For example, you can't drive a negative 7 miles to your friend's house. Even if you go in reverse, that's not traveling a negative distance. You're still going a positive distance. So that is also true about absolute values. They can never be negative. So, for example, let's say, example 3, this is. Let's say I asked you to find the absolute value of -5. By the way, these two bars around a -5 mean absolute value. So this is asking for the absolute value of 5. So if we look at a number line, -5 is over here. -1, 2, 3, 4, 5. How far is it from 0? Well, it's 1, 2, 3, 4, 5 units away from 0. So we can say the absolute value of -5 is 5. Similarly, so we'll call this part A. This will be part B. If I ask you for the absolute value of +5, 1, 2, 3, 4, 5, there it is. That also has a distance of 5 from 0. So the absolute value of 5 is also 5. Okay, so that is absolute value summarized there. The next thing we'll be talking about is comparing integers. Okay, and just a little refresher, if you want to include this in your notes. When we're comparing integers, we often use these signs here. This one means less than. I will say less than. Yeah, you know what? That's confusing how I wrote that. Let's say, I'll just put less than. This sign is a greater than sign. Sometimes two numbers might be equal, so that is the equal sign. This means equal to. All right, so we'll need those when we're comparing integers. So let's say I asked you, for example 4, to compare -2 and 8. That means put one of these signs in between them, depending on what's true. One way to, sorry, I meant to say -8. -2 and -8. Go ahead and change that. Sorry about that. Okay, some of you might know the answer to that already. However, we're going to look at a number line. So I'm going to put 0 here, and I'm going to plot both of these points. -1, 2, 3, 4, 5, 6, 7, 8. Here's -8. Here's -2. Extend that a little bit. All right, so the further left on the number line that a number is, the smaller it gets. So as you go more and more left on a number line, your number gets smaller and smaller. And then if you go right on a number line, your number gets bigger and bigger. Okay, so -2 and -8, which one's more left? Well, the -8 is more left. That means -8 is smaller. So if I were to compare these two numbers, well, if -8 is smaller, that means -2 must be bigger. So I need -2, the greater than sign is -8. This says -2 is greater than -8. So that would be comparing them. I could also, if I wanted to put the 8 first and the -2 second, or sorry, the -8 first and the -2 second, I could say -8 is less than -2. Since it's further left on the number line, it's less than -2. So I could put the less than sign there. I flipped the numbers around and I also flipped the sign. So these two things mean the same thing. You could put either one. All right, we'll do one story problem, and then we'll be done. So example 5. Let's say Wednesday, it was -1 degrees Fahrenheit. We'll assume it's the winter time. Thursday, it was -3 degrees Fahrenheit. Which day was warmer? In other words, which day had the higher temperature? So which of these numbers is bigger? You might already know that, but I'm going to go ahead and plot a number line here. So this is -1, -2, -3. So here are our two numbers we're working with. Remember we said the more left you are in a number line, the smaller the number. Therefore, the more right you are, the bigger the number. So the higher temperature means it's warmer. -1 is bigger than -3 since it's more towards the right. So Wednesday had the warmer temperature. So our answer would be Wednesday. Not much warmer, but a little bit.